Welcome back. This is problem B8N, so once again a no calculator problem. And so you tried this. They give us an information about the radius of the interior of a funnel relative to the height. And it starts out at h equals 0 all the way up to h equals 10. And the first thing they ask is the average value of this function over 0 to 10. And very straightforward question if you remember the average value of a function formula. And if you recall, this comes from that problem we did with the sloshing glass of water. And so the average value from a to b of this function is given by this formula. So 1 divided by the length of the interval. So in this case, 1 over 10 minus 0. And then we just evaluate the integral from 0 to 10. And I think the easiest way to do this is to pull out the constant 1 over 20. And then I have two terms, and I can integrate term by term with respect to h. And so very quickly, then I apply the limits, upper minus lower, and I find the average value. Okay, so that would be the average value of the radius. The next thing you want to know is, well, what's the volume of the funnel? And for this, what we're going to do is add up all these little disks all the way up. Okay, and so this is the disk method. So it's a volume of revolution. And the volume from height equals 0 to 10 is just the sum of all the volumes of the disks. And the disk method goes like this. It's pi r squared. So pi r squared, that would give you the area of the circular disk times the height of each disk, and I think I'm missing a set of parentheses there. And the height of each disk is a small change in h. And so now we have to square this, and that's how I get the 1 over 400. And that's just a little function I have to square, integrate term by term, apply my limits, and carefully answer using units. Okay. The next part of the question, liquid is draining. And so right away, this sounds like a related rates problem when they mention this. Okay, and they give you information. Okay, this is just a particular value of h. We wouldn't label that in our picture. Just remember that's where we want to evaluate whatever it is we're looking for here. The radius is decreasing. So that means that's a dr dt. And it's negative since it's decreasing, so negative 1/5 inches per second. And at that instant, they ask about the rate of the change in height, so a dh dt. And don't forget, we're given this relationship between r and h, so all we have to do is derive both sides with respect to t. And so I did that. Don't forget, there's a chain here. Okay, it would be 2h times dh dt since we're deriving with respect to t. And then just substitute values in and solve for dh dt. And as always, don't forget units. And don't forget that you probably want to answer, if you have time, questions like that with a sentence. All right, so the next problem we'll do is a calculator problem, B9C.